Okay, so in the previous meeting, we cover unsupervised. We cover how clustering can be used to categorize document. Okay, for this meeting, we are looking into another type, which is categorized as supervised learning. So this is like a preliminary introduction to machine learning that you will cover next semester. Yeah. So we have covered clustering and also naive text categorization. And for today, we will cover supervised learning, in which we cover the decision tree and also the can-and classifier. Okay. So can you see the screen, the PowerPoint presentation? Okay. Okay. So the difference between unsupervised and supervised learning is that for the supervised learning, we need to have the label to guide us to model your algorithm, right? Every that some kind of scoring. So the more you score, the higher is the accuracy. Okay. So for instance, if you look at the diagram shown here, so basically you will have your full data set here, but you will divide them into training and testing. So training set is used to train the model. So normally we can divide them into 90% and 10, or you can have a variety. So for instance, you can divide them into 80 and 20 or 70 to 30. Okay, so each data set that you have will behave differently depending on the type of document that you have. So you may have a short article or long article or only the title only. So once you have divided them into two, and bear in mind that for each of these documents you have, okay, so the labels is used to model your learning algorithm, in which it will fine tune all the parameters that you have in the learning algorithm depending on which type. Okay, next semester you will learn more about machine learning. So we have so many types of machine learning and what are the parameters involved and how it affects the accuracy of the model in learning your data. Okay, so once we feed this training data set into the model, so we will fine tune here. So depending on what algorithm you use, but today we will look into the decision tree and also the K classifier, can-and classifier. So once we have trained them, so this is considered as optimized because we have find the best setting, the best hyperparameter setting that can produce the highest accuracy. So once you have the model, we apply the test set to validate the accuracy. Okay, so we apply the model. And then we equal the that we can get the classification correctly identified. Okay, so that is the whole process that we have. So we have the training data set and each one of them label. And when we say find a model here, meaning that we will optimize the model or we may try different model. Okay, so for instance, we can use a part vector machine, or we can use the NN, or we can use decision tree, or we can use naive bias. So many algorithms. We can even, for instance, we use the um, what do you call it, neural network in order to classify the document. So the whole idea is we want to be able to predict the level of the unseen data set. So how do we verify or validate the accuracy? We have to use the same data set that we have reserved for testing. Okay. So the main ingredient here is here we need to be able to say, okay, we have this training set function that will be able to assign the class label to the unseen data that we have. Okay, so if they belong to that class, we will assign 1. If they are not belong to the class, we will assign 0. Okay, so this is the training set function that is used to fine tune your model here. Okay, so for instance, given a document here, and then we have the class 1, class 2, and class 3. So that the training set is used to classify this into all these classes, and we want to know how many of them are correctly classified. Okay, so we are fine-tuning your algorithm here. So once you have the maximum setting here, no, the setting that produce the maximum accuracy. So you will take this one. Okay, you will fit into the classifier, and then we produce the classification result, and we compare with the actual set that we have initially. Then we will compare. Okay, so that is the whole process. So when you want to do, I understand that you all will be doing your final year project. So for most of the students in the data science, they are looking into how do you perform classification, how do you perform clustering, but more into the application of the domain. For instance, you want to predict whether, no, you want to use prediction to predict disease, or you want to use specific disease that you have, or all these using machine learning. Some people will look into text, where in the text they are looking into sentiment analysis. This is classification as well. You also looking at the can you hear me? I think I have problem with my network. Okay. So for this one, we are looking into how do we apply classification for text. So for instance, we are looking at the sentiment. How many people say positive about certain product, negative about certain product, or neutral about certain product. So we want to know how people review a certain product so that we can improve our services. Okay. So the supervised learning that we have, we will have one classifier that is trained and validated. So train means we fine tune the hyperparameter that we have, and it can be used to classify new unseen document. So if we have new unseen document, it will automatically assign class label to that particular document. And if we have a highly well-tuned classifier, then you will have very effective classifier. So, so the key area here is that we need to have a very good training data set, and we also have optimized the classifier. Okay. So for this session, we will look into two classifier. The first one is called decision tree, and the second one is called k-nearest neighbor. So I believe we have covered this one more or less in the previous lecture, where the k-nearest neighbor depends on what? Depends on the distance, right? Okay, and decision tree will depends on certain benchmarking on how they will split the grouping into sub grouping um, by assuming that they will fall into the same classes. We, we will look into this one. Okay, so now let's take a look at the first one, decision tree classifier. So decision tree looks like this. They have the root, and they have the vertex here, and we have the edge here. Okay, and whatever you have at this level, this is the class level. Okay, so this is the decision tree looks like, but in this one we are looking into this relational table. How do we predict whether we want to play or not, depending on the four independent variables that we have. So this is your dependent variable, and the rest is independent variable. So we consider them independent variable because they are used to predict your dependent variable. So um, so for this one, we start with the outlook. So if the outlook is sunny, we go here. If rainy, we go here. If overcast, we go here. So depending on the unique variable that we have here. Okay, and it will continues until we have down here. So we will decide to play or not play depending on which path we're going. Okay, so for decision tree, they are organized as path in the tree, because if you look at the path here, so one path here, you will have here. So this is considered as one predicate. So predicate here saying that if you have outlook equal to sunny, and you have humidity equal to high, so we are saying that we will not play. Okay, so this is the predicate or expression of one of the paths that we have in the tree that we have here. Okay, but the question that we want to ask here, how do we actually construct the tree? So we as a computer science, as a computer science student, we want to know how we construct this, not only to apply, but how do we actually construct this tree. Okay, so how do we apply this one? Okay, given that we have this data set, okay, so we want to decide whether we want to play or not. So depending on the value that we have here, we just plug in the value here, variable applicable, for example, the outlook is sunny, and then now we have humidity is high, so we are going here. So this is the the class label that we assign. Okay, so the decision tree is a very good model in which you can explain the result, why this item is classified as no or yes, or class 1 or class 2, and so on. Okay, so there are you can explain why certain item is classified as X or Y. Okay, so the issue that we want to look here is that how do we do the splitting process? So for instance, we go back here, we have this outlook, right? So this outlook, we choose, let me erase this. Okay, this outlook, we are looking at in here, right? So the question is, why didn't we use windy or temperature in order to start first? So we need to ask the question why we didn't use temperature, humidity, or windy. So why did we choose outlook? Okay, so there is a reason why we choose this variable. So we need to understand how is the process that we want to split the data that we have. So for instance, if we start with the outlook, so for the outlook, we have 3 unique variables. Okay, from here, we can further split using the humidity, and then the windy, and then finally we have this. Okay, so we start from the root of the tree, and then we further go down until we have or met the stopping condition. Okay, so the stopping condition might be you reach the maximum number of depth, which is how many level you want to go down, or you have achieved in which all the member here belong to the same classes. For instance, okay, first you split them into sunny, rainy, overcast. So you want to know what are the labels for all the member here. So if all of them belong to the same class, so we stop. If no, we split them further. Okay. So in looking into the membership or looking into where to split, we will look into benchmarking. But if we try to make an analogy, okay, this is based on the table that we have, based on these tables, right? So how do we apply this for text classification? So for text classification, basically we do the same, but we use keyword to split them. Okay. So here we will have the vertex, the edge, and also the root. So the root is the starting point. So the vertex refer to all the document that consists keyword that assigned here. Okay, and the edge is a path connecting the root to the vertex and to another vertex and so on. Okay? So for instance, if we use the keyword A, B, C, D, no, A, B, C, H, so we only have this label, and then we further split them using keyword D, keyword E, and keyword F, G, and so on, and CA and CF. Okay, so no, this is the class A, and then the class F and A, and then class C, and so on. So if we look at this is the class label, and this is the keyword used to split the type of document that we have. So we use keyword. Okay. So we will continue going down until we meet the stopping condition. So the stopping condition could be the first one is we reach maximum depth, okay? Or we reach where all member belong to same class. Okay? So how do we start? What formula we want to use? Okay, so before that we will define here. So before we can start the splitting process, we have to know how many classes we have. Okay, no, how many keyword we have. Okay, and also we're looking into how many classes we have. So we have the keyword, we have the classes, and we have the logical predicate of the index term. So this is the expression that we built from the root going down until you reach the class label. Okay, so we have the vertex, we have the age, we have the root, and also we have the a function that associate with internal node of the tree, one or more index. So this is for the index. This is for the class, and this is for the predicate. Okay, so we have the keyword, we have the class, and also the predicate that we have from the root going to the class label. Okay, so how do we start? So first step, we will associate all document with the root. So we put all the document here. And then the second step, okay, we select the index term that provides a good separation of the document. So basically in this example, we will choose four keyword, and then we will split them. So they are chosen based on certain calculation. So we want to know what is that calculation, what is that formula that we use. Okay, so in the third step, we will repeat until the tree is complete. How do we know that the tree has completed? We will refer to the stopping condition. Okay, so we start from this, going to the second one, and then the third one. Okay, any question? So belum lagi we masuk into the formula, how do we actually split the document into few subgroups? Okay, so if you are okay, can you type number 8? Okay. Okay. So we will look into the splitting criteria based on the information gain. So we say information gain because before we split, we have less information. After we split, we have more information. Okay. So we use this what we call entropy, or they call it the measurement for purity. How pure is the membership of one class? Okay. So over here, we have the summation of all the probability of that class the probability of that item belong to the class in that group Okay, and we take the log, and these two are the same. Okay. So the entropy measure how pure is the membership in the subgroup. If they are pure, that means the value will be 0. If they are 50-50, means that half of them belong to another class and another half belong to another class, so you will get 1. Okay, so I will go some example here. So we're looking at this entropy. Entropy refer to how pure is the group that belong to one class only. So for instance, we have 3 groups here, 1, 2, 3. Okay, so this refer to the class label. So class 1, class 2, and class 1 and class 2. So if we look at this membership for this group, so the probability of having class 1 is 0, and the probability of having class 2 is 1. Okay, so we will plug the value here. So looking at this formula, so looking at this summation, so basically we are looking into how many classes that we have this is how many classes that we have. Okay, so in this case we have 2, so we have 1 and 2. Okay, so we plug in, since they have all the member belong to one class, which is class 2, so the value of the entropy is 0. So if we move from 60 to 51, the value for your entropy getting higher, and the highest would be if you have 3, 3. Okay, half belong to the class 1, half belong to class 2. Okay, so the aim is we want to split in such a way that you will have lower value for the entropy for each of the group that you have. Okay, I'll give you another example here. Okay, so if we look at here, we have keyword A, B, and C, and we have 18 documents. So when we split the document using keyword A, B, C, we will have this. Okay, so we can compute the entropy for each of the group. So for each of the group, we will have this. So this is 0, 0.65, and 0.92. Okay, so what we want to do next is we want to summarize this. How do we add up all this value? Okay, so how do we add up all this value? So we will look into the weightage of this. The weightage of this is so all of them 666. So that means the total entropy for all of this for one set, the total entropy equivalent to 6 divided by 18, because the first one we have 6 out of 18, right? We have 18 document here, so we times the entropy, and then we repeat again 6 over 18 times 0.65, and then plus 6 over 18 times 0.92. So this is the accumulated entropy for the whole scenario. But if we look at individual subgroup, this is the entropy for individual subgroup. So what we want to know is this one. So if the total is lower, that means you have high purity of membership for each of the group that we have, that means the keyword we use here is good. Okay, so if we want to look at the formula that we have here, so we go back this one. So so this is the accumulated entropy. So this is the weightage. So the I here refer to the number of group that you have partitioned them. Okay, so this is after you splitting, this is after, and this is before. Okay, so the difference between before and after is considered as information gain. Okay, so for instance, if we have initially we have this, for instance, okay, can you guess what is the entropy for this? If you've been listening, what is the entropy for this? So the definition of entropy is the measurement of how pure is the membership in that particular group, right? So the lowest value showing you that they have high purity. So what is the entropy for this? So the membership is 50-50%, right? So what is the formula here? So the formula here is negative 0.5 log 2 0.5 times 2. So what is the value for this? Can someone assist me? It should be 1. Do you understand how to get this? So basically for this one, we have 3/6 log 2, 3/6. So this is for the A. Okay. And then we will have plus here. So this is for the B. So the B is 3/6 log 2, 3/6. Okay. So this is similar to that, right? Okay, so what is the value for this? Anyone? One, right? Thank you, Tam. So the answer is 1. So for the initial one is 1. So the entropy for this is 1. Okay, let's suppose we have split them using keyword. So the entropy here is 1. So let's suppose we use the keyword X and Z. But for this one, we have A, B, and then over here we have B, B, A. Okay. So what is the entropy for this? So we can say that this is 2/3 log 2, 2/3 plus 1/3 log 2 1/3, right? So this is for the A, this one is for the B. So what is the value for this? Anyone? So we're trying to find the entropy for this only at this moment. So we have 2A, 1B, if and this document consists of this X. So what is the value for this? Someone? Okay, 0.92. So the entropy for this one is 0.92. Okay, so what is the entropy for the second group? It should be the same, right? Because they have 2 and 1. So for the second one, we also have 0.92. Okay, so this is 0.92. So how do we total up this one? Okay, so the total entropy after we split should be, because we have, this is the weightage, 3/6 times 0.92 plus 3/6, 0.92. So this is the total entropy for this. Okay, so what you get for this? (0.92). Kan? What is the entropy for this? Okay, so the entropy is 0.92. So if we compare, okay, this is before we split, this is after we split. So what is the information gain? How much is information gain we have? So we have this. So this is the initial one. So the initial one is this. Before we do the splitting is 1 minus 0.92. So the information gain is 0.08. Okay. So we may use different keyword here to split them. So the goal is to maximize the purity of here so that the value for your entropy is lower. So when this is lower, so we maximize the information gain that we have here. Okay. So let me give you another example here. Okay. So for this one, we have another example. So we have 18, but the composition of number of document is different. So this is 9, this is 5, this is 4. Okay. So we have the first group, we have 0.92. Okay, and the second group we have 0.0. So before we do splitting, we have this one. So we have the 15, and for the C1, and also we have the 3, so the C2. So we have 0.65. Okay, so to compute the info gain, so we need to take this one and put it here, but the weightage is different here. So 9/18 because we have 18 document here. And then this is 5 because we have 5 document here and 4 document here. Okay, so when we add up all this, we have this. Okay, So the info gain here is 0.19 in this example. Okay, so if we compare with the previous one, so this is where we have 666. So the accumulative entropy for all of this will be 0.53. So the info gain is 1.12. So compare with this, which is 0.19. So we can conclude that splitting the document using keyword CDF is much better compared to splitting the document using keyword ABC. Okay. Of course, this process will be continuous one because you will try so many combination of keyword. So the idea is what is the best keyword that you can put up in order to get the highest purity. Okay. So I give you some exercise here. So later on you can do this one. So who knows, it will be in your final exam, kan? So in this example, we have 20. So we have 10 document here. So of course, based on here, the initial entropy will be 1, right? Because 50%. So over here, X, you get 9 document. And then Y, we have 5 document. And then Z, we have 6 document. Okay, so find the entropy and then find the accumulated total entropy minus 1. So very easy. Okay. The problem with this one is that when you have new unseen document, but they do not contain the keyword that you use to construct the decision tree. Okay, so that is the problem here. So what happens is that you will need to continuously update your tree here. So that's why they said delay the construction of tree until new document is presented for classification. Or you can build tree based on feature presented in this document, avoiding the problem. So you keep updating your decision tree model. Okay. Okay. Any question? So for your information, this entropy will be your foundation for the machine learning course that you will be taking next semester. So very easy. Okay. If you're still there, can you type number 3? Okay, for the next one, this is a straightforward classifier where it will try to assign the label of the unseen document based on the majority of the nearest neighbor labels that we have. So that's why they call it the K and N. Find the nearest neighbor. Depending on K could be 3, could be 5. And then based on the majority label that we have for the nearest neighbor, we will assign that one to the new unseen document that we have. So they call it lazy classifier because we do not build any model. Compared to decision tree, we need to build a tree. For the K and N classifier, we do not need to train them because they depends on the calculation of the distance, the computation of the distance between the new unseen document to the store document in your database. Okay? So it depends on your K here, how many you want to look into or take into consideration when you want to assign the label. And the issue again here is what is the best case? Okay. So for instance, this is your new unseen document here. So what you want to do is you want to assign to class A or class B. Okay. And of course, you will depends on the K here. So in this example, we have 4, right? So 4 nearest neighbor. So majority of them coming from class B. So we will assign this one to class B. Okay. So we do not need to model them. So we just compute the majority label for the K and nearest neighbor. Then we assign that label to the document. In case if they have same number of labels, so you have to set the default. Okay, or maybe you can check the average distance between these two classes. So although they have the same number of document that belong to class A and class B, which become the nearest neighbor, so we can also compute the average distance. We compare between class B to class A. So everything to do here is we just need to compute the distance. So when we have this document J, and then we want to assign the class membership here. So basically what we want to do here is that we want to get the label for individual document which become the nearest neighbor of this document. So we will count this on how many of them. Okay, we will count. So we will assign the label depending on which one will give you the highest number of document. No, yeah. Okay, so the classifier assign the document with the classes CP with the highest score. So score here refer to the number of nearest neighbor that we have. Okay, so this is the simple assignment here. So for instance, we have a new document, and then we compute the distance between the new document with respect to the other document. So we have all the document here with the distance that we have here. And this is the label that we have. Okay, so depending on the K that we choose here, we have 1, 2, 3, 4, 5, 6, or 10, or even 10. So we will assign the label to that document 1 depending on K. So if we choose K equal to 4, so that means here, 4 nearest neighbor. So in this case, we have 2A and then 2B, right? Okay, so we can assign a default class, or we can compute the average. So the average, we compare this and this. Okay, so if we are looking into 7 nearest neighbor, so 7 nearest neighbor, we have this. So the majority will be A. So we will assign that document, new document with class label A. Okay, so very straightforward. So the skill that you need to know here is how do you compute the distance between the new unseen document to the rest of the document that we have. So this is very tedious because if you have 1 million document, then you need to compute 1 million times, right? Okay, so that's why it's better to cluster your document first. Okay, cluster your document first. Then, for example, if you have 1 million document, you have 10 cluster. So you only take 10 calculation, and you take the nearest cluster, and then from the nearest cluster, you take the 10 or k and nearest neighbor that we have. Okay, so this is the problem with Canon performance. We need to compute the distance between document to be classified and all training document. Okay, and another issue here is that what is the best value for K? So again, you will have to try many times. For example, for data set 1, so you will try K value equal to 1 up to 10 maybe. And then for data set 2, you maybe need K equal to 1, the same. Okay, and data set 3, you may have to have K equal to 1. So based on the result that you get, then you can justify which K that will give you the highest accuracy, because you have 3 data sets. Okay, 3 data sets. Okay, so I think that's all for today. So basically, what you need to know for this one is that we can perform unsupervised learning or supervised learning, and depending on the task that you want to do.